we have been asked to draw a graph of y is equal to x squared minus x minus 5 over the range or domain -4 less equal to x less equal to 5. So we use the graph to solve common 1, x squared minus x minus 5 is equal to 0. This question can also be framed as find the roots of the curve. Then we are also asked to use the graph to solve x squared minus 2x minus 8 is equal to 0. So the first thing we do is to draw the graph, and we can only do that by getting the coordinates, some of the coordinates on which it passes. Therefore, we need this table. Now, the first row consists of the values of x, which we have gotten from the range that we are supposed to draw the graph over. And see, we are supposed to draw from -4 up to 5. So that's why I have -4, -3, -2, -1, up to 5. Now, after you have done that, after you have identified the x values that you want to get their corresponding y values, split this quadratic equation into the constituent parts: the first term, the second term, and the third term, or the quadratic term, the linear term, and the constant term. So we have x squared, then minus x, and then minus 5. So let's get the values across. X squared means these values, you keep squaring them to get the values right here. So -4 squared gives us 16, -3 squared gives us 9, -2 squared gives us 4, this gives us 1, 0, 1, 2 squared gives us 4, 9, 16, and then 25. Now this second one, -x, means you take the value that is here, you reverse it, or you multiply by -1. So -4 times -1 will give us 4. This one times -1 will give us 3. Then this will give us 2. This will give us 1. And this will give us 0. And then minus x. Here x is 1. So minus of that is -1. Is -2, -3, -4, and then -5. Now for this one, this is a constant. It does not depend on x. So we'll just replicate it all through. So that's why we have it as -5 all through. Then you start now summing up from this downwards. You don't include the x values. So we have 16 plus 4 giving us 20 minus 5 gives us 15. 9 plus 3 gives us 12 minus 5 gives us 7. 4 plus 2 is 6 minus 5 is 1, all the way up to 16 minus 4 giving us 12 minus 5 giving us 7, then 25 minus 5 giving us 10, 20, then minus 5 gives us 15. When we are done with that, now the x values here, in conjunction with the y values we have calculated here, remember this is the equation which is representing y. So this one and this one will give us a coordinate to plot. This one and this one will give us another coordinate to plot. This one and this one will give us another coordinate all the way up to this one and this one. So here is the graph I've drawn. So you can see we have -4, 15. -4 is here, and the 15 is here. So we have the point here. Then we have -3, 7. -3 is here, and then 7 is here. That's the point. And that's how we have plotted all of them in that manner up to the last one, which is 5 and 15. And you can see 5 is here, 15 is here, so the intersection is that. So after we have drawn the graph, we are asked now to use the graph. First of all, you need to label the name of the graph. This is the graph y is equal to x squared minus x minus 5. Then now we have to use it to solve x squared minus x minus 5 is equal to 0. If you look at this equation we have here, it is actually the same as what we have here, or that we have a 0 here. So what it means is that you simply look for where the graph intersects with the x-axis. Now in our case here, the graph intersects with the x-axis here at negative 1.75 and at negative 1.750 and at 2.750. Take the x coordinates, that's negative 1.75 and 2.75. That will give you the roots of the curve, or it will give you the values of x. In other words, you will solve by just taking the x coordinates of the intersection. So we shall have the curves intersect as we have said at this point, and therefore the x coordinates of these intersections gives the roots, and the roots we have said are negative 1.75 and 2.75. Then we come to the second question, which wanted us to find or to use the graph to solve x squared minus 2x minus 8 is equal to 0. So in that case, you will take the two equations, the one that we have used to draw the line, subtract the equation that we want to solve. So that's what we have done here. You can see the first one is the equation we have used to draw the graph, and the second one is the one we want to solve. On that, I've removed this equal to 0 from this side to this side so that it can enable me subtract them. So once you have written them like this, you subtract them. So y minus 0 gives us y, this gives us 0, this gives us negative x minus negative 2, that's like negative x plus 2 giving us x, and then minus negative 5 or minus 5 minus negative 8 gives us positive 3. It doesn't matter which equation you write on top, the answer will remain unchanged. Even if you write this one accidentally first and then this one is written later, the answer will not change. So this one is an equation of a straight line. You can see this y is equal to x plus 3. So let's get some of the coordinates on which it passes. So I've picked these 3 points to assist me getting the points on which it passes. So when x is negative 1, y will be negative 1 plus 3, and that gives me 2. When x is 0, y will be 0 plus 3, giving us 3. And when x is 3, y will be 3 plus 3, giving us 6. So let's plot these points on the same graph. Negative 1, 2. Negative 1, 2 is this point here. And then 3, 6. Let me take 3, 6. 3, 6, 3 to the 6 is this point here. So you now join them with a straight line and then label the line. It is y is equal to x plus 3. Now where the line will intersect the curve, that is the point of interest. So you read those coordinates of the points where the line cuts the graph. It cuts the graph at negative 2, 1 and 4, 7. Concentrate on the x coordinates. The x coordinates will be the values that we shall need to give as the answer. So as we have seen, the graph intersects at negative 2, 1 and 4, 7. The x coordinate is negative 2 for this point, and the x coordinate is 4. So that means x is equal to negative 2 and x is equal to 4.